Hey everybody, welcome to our lab on the electrocardiogram, the ECG or EKG. Either one is good. So, what is an electrocardiogram? That's the question we got to answer. So, basically, an electrocardiogram is a recording, and that's what the gram part here is means. So, an electrocardiogram is a recording. It's a recording of what? So it's a recording of something, okay? It's a recording of the, put it in there. It's a recording of the heart's, what? Of the heart's electrical activity. So if we turn that word around, we can basically unpack it. An electrocardiogram, ECG, EKG, is a recording of the heart's electrical activity. Now, what does that mean? Well, basically, an electrocardiogram is a graph, all right? It is a graph, and this graph has voltage on the y-axis, and that's the electrical activity. That's what's changing in the heart as time passes on the x-axis. So an EKG is basically a graph, voltage versus time. Okay? And for much of this graph, so here I have a typical EKG trace, and for much of this graph, the line is straight. When the line is straight, that is known as the isoelectric line. ISO, you've met ISO in like isotonic, isometric. ISO means the same, like staying the same. So the electrical activity, the voltage, is staying the same during these isoelectric periods. Now, there are also periods when stuff is happening. And every time something is happening, we're going to see the line change from being isoelectric. So like, for example, here it goes up, comes back down. And then we got it going down, up, and then up again over here. These are electrical events. This electrical event right here is known as the P wave. P actually doesn't stand for anything at all, so don't try and like puzzle that out. The P wave is going to represent atrial depolarization. So remember, if we think about the heart and the two atria, there's a nice looking heart right there. Get some blood vessels going on. Yeah, look at that beautiful heart. But we know that the depolarization happens at the SA node, which is somewhere up here in that right atrium. Then the depolarization spreads throughout the atria before it goes down into the ventricles. And so this P wave is a measurement of that atrial depolarization. Now, if the P wave is atrial depolarization, no surprise that this trio of events here, which is known as the QRS complex, no surprise that it is ventricular depolarization. So there's actually three electrical events here. There's this downward triangle, that's your Q wave. Then there's this big upward triangle, that's your R wave. Then there's this downward triangle here, that's your S wave. And the three of them, we mush them together and call them the QRS complex. And that is representing ventricular depolarization. Of course, the ventricles are much bigger, much more cellular than the atria. So no surprise that their electrical event is bigger and more complex. All right. If we keep on going, we have one final wave. It is called the T wave. It is known as ventricular repolarization. Remember, when cells depolarize, they'll subsequently repolarize. And the T wave here represents ventricular repolarization. Now, I do want to point out, we see atrial depolarization. That's our P wave. We see ventricular depolarization. Then we see ventricular repolarization. Well, where's the atrial depolarization? Thing is, it's happening at the same time the ventricles are depolarizing. That's why we don't have a fourth, like, separate wave for that. All right, those are all of my basic electrical events. And what I want to do with my EKG, I just realized that the word measurements here is totally not spelled correctly. So we gotta fix that, okay? Let's pop a little E in there. There we go. Much better. Two basic EKG measurements. One thing we can measure is voltage. Like how much voltage, in other words, how tall are these different waves? How many millivolts of electrical activity do we have during these different events? The other basic thing we can measure about an EKG is time. Like how long did it take for something to occur? So I can measure the voltage of my events and the duration of my events. Now, if I'm measuring voltage, I can measure the voltage of my P wave. And again, if I'm measuring voltage, I'm measuring how tall it is. I could also measure the height of my Q wave, my R wave. Notice that if I did the Q wave or R wave, it is helpful to draw a line like that. And if I were measuring the Q wave, let's do the R wave. If I were measuring the R wave, I'd measure from the peak of the R wave to this line that I drew. Okay, that's the bottom of the R wave right there. I can measure the voltage of my T wave by measuring, again, it's helpful to draw a line. Helpful to draw a line here too. And I can measure from here to here. Okay, so I could measure the voltages by looking at how tall these guys are on my graph. I can do it for all these waves, and this can be indicative of the size and the health of my chambers of my heart. Okay, let's keep on going. Here I have a nice little EKG trace on some EKG paper, and I want to go through how we measure ECG voltages. Well, what I would do is I would count how big my P wave is in terms of its height. Notice it is one of these little boxes tall. Each of these little boxes is 1 millimeter. So my P wave here is going to be 1 millimeter tall. So if I imagine my extended line right there, from that line to right there, that is one box. That is 1 millimeter. Now it is a standard on our EKG devices that 10 millimeters is the equivalent of 1 millivolt. So what I'm going to do is I'm going to take that 1 millimeter that I measured, I'm going to multiply it by 1 millivolt over 10 millimeters. My millimeters is going to cancel out. I'm left with 1 times 1, which is 1, divided by 10, and I get 0.1 millivolts. And that's my answer. If I were doing the R wave, so I would draw a little line right here, and I would count how many boxes tall this is. And I got, what about 1 plus 5 is 6, plus 5 is 11, plus 4 is 15. So for my R wave there, it's 15 millimeters. And what I'm going to do is I'm going to multiply that times 1 millivolt over 10 millimeters, and that lets me cancel out, get rid of my millimeters, boom, boom, and I'm left with 15 over 10, which if you need to, bust out that calculator, but that's simply 1.5 millivolts. Easy peasy. Count and divide by 10, and that's how we do voltages. Now, I could also measure how long things took to occur. And there's, in fact, 4 intervals I have to be aware of. There is an interval called the PR interval. It's from the start of the P wave to the start of the QRS. That's kind of weird. It's called PR, but you can think about it as being PQ. It's from the start of P to the start of QRS. It's basically how long it takes for the atria to depolarize and for that depolarization to get to the ventricles. I could then measure my QRS interval. That's from the start of my QRS complex, so my start of my Q, to the end of my QRS complex, the end of my S. And that's how long it took the ventricles to depolarize. I could also measure my QT interval. That's from the start of my QRS all the way to the end of my T. And that's how long it took the ventricles to depolarize and repolarize. I could then measure my TP interval. That would be from the end of T, so from the end of T, all the way to the beginning of the next P. And that's the time in between beats. And this can tell us about the heart's ability to conduct electricity, which is also indicative of its health, of its size, and of, lots of different problems that can occur. All right, but then how do we actually do the calculations? Well, suppose I was measuring my PR interval, all right? I would measure from the start of my P to the start of my QRS. And if I look, I got 1, 2, 3, and about a half, so I'm going to call it 3.5 boxes. Of course, you get a little wiggle room as you eyeball it. So 3.5 millimeters. Our machines are set so that 25 millimeters is 1 second. So what I do is I multiply that 3.5 times 1 second over 25 millimeters. Millimeters cancel out. I get 3.5 over 25. Plug it in my calculator or do it in my head, and I get 0.14 seconds. No matter how I'm doing, no matter what interval I'm doing, it's always the same way. I count how wide something is, and then I divide by 25. That's it. It's not bad. All right, another thing we can do is we can measure atrial and ventricular rates. All right. Now, of course, I could measure my heart rate by measuring my pulse rate. I could put my fingers on my radial artery and I could count. Okay. But that pulse rate that I'm getting there is really my ventricular rate, because every time I feel a pulse, it's because the ventricles pumped out blood. So what's nice about my EKG is that I can measure the rate for both the atria and for the ventricles. It should be the same. Okay. Now, let's do atrial rate first, okay? If I'm measuring atrial rate, I'm going to measure my PP interval, okay? That's from the start of 1P all the way to the start of the next. And I'm calling it about 19 millimeters in this particular example, if I count the little boxes. Now, earlier we established that 25 millimeters is 1 second. What that means is there's 1,500 millimeters in 1 minute. I just multiplied each side by 60. So I know in this PP interval that I established here, like between these two green lines that I just made, there's only one P wave in there, which means the atria only depolarized once, which means the atria only contracted once. So I have one atrial contraction in that 19 millimeter span. If I multiply that by 1,500 millimeters over 1 minute, so millimeters is on the bottom over here, and on the top over here, so it cancels out, I end up with 1,500 over 19, and I get a little less than 79 atrial contractions per minute. Now, if I was doing ventricular rate, I would do the same thing, but instead of doing the PP, what would I do? I would go from R to R. And then at whatever number I get, I just divide it into 1,500. Again, all we're doing is counting and doing one mathematical operation. It's really not that bad. So yeah, that's how I do atrial and ventricular rates. I don't even want to talk about EKG leads. I'm going to leave that alone. And so yeah, hey, that's it. Short video today, 14.5 minutes. Hopefully you stayed through the entire time on this one. And I'll see you later. Bye.